Well, welcome everybody. I don't know if after lunch is the best time to have it because everybody's going to start nodding off. That's okay. I may use this laser tag on you if you're not off, but you won't know it. So my name is James Serra. This session is building an effective data warehouse architecture. I, until recently, was an independent consultant, and about 2.5 months ago went over to Microsoft as a full-time employee, called a technology solution professional, specializing in the parallel data warehouse. That's a whole other topic, but it is my job now and has been for a while to help people build data warehouses. And so that's what this topic will cover. So let's start it off. How many people here in their companies have what they would call a data warehouse? Wow, good. How many people here have what they would consider a really well-built data warehouse? And how many of you are lying? All right, okay. So one of the things we'll cover is what really is a data warehouse, because there's a lot of confusion out there. So I go to a lot of clients, even Fortune 100 companies, and their definition of a data warehouse is not quite what fits in with my definition in there. This whole thing came about many years ago. I was a DBA. I was a DBA for about a dozen years. And how many people here are DBAs? Wow, recovering data, accidental DBAs, a lot of types of DBAs. So my boss came to me and said, hey, James, I want to build a data warehouse. And I was a production DBA / developer DBA. And he said, I've been reading a lot about it. I think it'd be good for a company. And I said, do I get a bonus for this? And he said, no. I said, well, I don't want to do it. He said, well, you're going to do it anyways, so go learn about it. And at the time, I didn't know anything about data warehousing. So during my course of investigating, I found people talking about Kimball and Inmon and tabular and relational, and I don't know what the heck was going on. So I started educating myself, and those experiences are what I'm trying to bring to you today, of what I learned and what are some of the definitions of data warehouse, data mart, how all this terminology and these possible ways of creating a data warehouse, what's really the best way? Because my goal here is to give you some kind of roadmap and understanding of what other companies are doing and I'd like to say there's one shoe that fits all, but you're going to find there's a lot of exceptions to building a data warehouse that we're going to cover. So that's my background. It's a whole bunch of fluff. I'm a Microsoft MVP, but they actually take it away when you become a Microsoft employee. But they still give me one of these, so don't tell anybody that they've missed out on that. So we'll talk about what a data warehouse is not. We'll talk about a fast-track data warehouse, or why we use a data warehouse, a bit about appliances, the terminology, data warehouse, data mart, the Kimball and Inmon. That's where we really get into pretty deep. We'll briefly cover how to populate a data warehouse, ETL and ELT, the difference. A little bit about Surrogate Keys and SSAS Cubes, and I'm going to touch on a modern data warehouse, which is something new to this presentation. So what a data warehouse is not. And I had a number of clients who thought a copy of the source database with the name prefixed with DW was a data warehouse. I've actually probably had 6 or 7 companies that thought that. When I looked at the data warehouse and saw it was exactly the same as the source, they said, yeah, but it's got DW on it. And I said, well, it's not really a data warehouse, but there are people who believe that. A lot of them may have multiple ERP systems, CRP systems, and what they do is they write select statements on, say, the customer table, and then that points to each one points to a various different source system, and they union them all together, and they think that's a data warehouse system. Well, it's not. You're just kind of overlaying and making things more difficult. Dumping ground for tables in various sources. And this is how many companies I go to. A data warehouse starts out by somebody wants a BI report, and they want to pull from multiple systems, so they grab the data from there, write some ETL, dump it in the table, and then the user says, well, now this is great, but can you add this extra data on there and this other source system? And they write some ETL and they dump it in there, and pretty soon that becomes a really big mess with no upfront design. It's just kind of build as you go, and those are where a lot of problems lie, because then you start problems with performance and versions of the truth, and everybody's building their own thing, and then you get into everybody's writing Excel and exporting it out, and it's a whole big mess. That's not a data warehouse. So this was something I saw a while back from Wayne Erickson built a little model here that I thought was great at showing where people lie in going from just a reporting system to the end goal of a enterprise data warehouse. I find a lot of companies are in between the spread marts and the data marts. So the spread marts are where everybody and their brothers got an Excel spreadsheet and they didn't want to wait for IT to get things done, so they go do it on their own, and now they have a version of the truth and somebody else has a version of the truth. It becomes a big jumbled mess. And then you go on to some of those departments create their own data marts. And again, they're doing things independent from IT with no coordination among the various departments. Now you got all these data marts to support. Then it may go on to a data warehouse where they combine some of those data marts, but you wind up with multiple data warehouses. Well, the end goal is to get to the enterprise data warehouse, one single version of the truth where everything starts. And you may branch out and create data marts from that in a kind of a hub and spoke environment, but ideally you want to get an enterprise data warehouse environment. I would say maybe 10% of the companies that I visit have something like that. Some of them even have multiple enterprise data warehouses, which I don't know what that means, but they have it. So, what is a data warehouse and why use one? Here's the reasons that many people, including me, have come up with. They're quite common. And preferences, this is not an OLTP database, OLTP situation. If you have a read-write heavy transactional system, a true source system, that is separate from what we're talking about here. I still find people try to migrate their data warehouse into an OLTP environment. And I say you got to concentrate on what a data warehouse is, and it's not OLTP. The reasons you have one, reduce stress on the production system. So a lot of companies, they get a source system, they want to do some reporting off of that, and they're writing queries to that. And you got some user writing Excel, and they write some god-awful query, and it takes the whole server down. How many people have been in that situation before? Yeah, a lot of you. And then you become familiar with the kill command, right? So the first thing I do when I was a DBA and go to new clients is let's get all that performance issues out of the source system and put it on a data warehouse. Let's move the data over. Even if we got to mirror it, at least the first thing we're doing is removing that issue. And so that's a primary goal of a data warehouse is reduce the stress on the production system. So, and then it becomes optimized because, again, if it's not an OLTP, you're not worried so much about writing. You're worried about creating indexes and doing things and maybe using a certain appliance on there that's going to generate fast read access because that's what 90% of reporting is. You'll have the period during the day where you're going to write data to it, but most of it's going to be optimized for the read access. Integrate many sources of data. So you'll start out with maybe a couple, usually financial. You pull it all into a data warehouse, but then you want to pull in production data from CRM systems, other ERP systems. A lot of companies are in predictive analytics now, so they may pull in data that has forecasting and budgeting and such. So you want to have your data warehouse as an area where you can dump all these particular systems in there. Keep historical records. Many times I go to a company and what I find is when you want to go back in history, they have a nice SharePoint site or even worse, a file share site. They have all these old hard copies because at the month end they just create the reports and they dump them in there. They don't have any way to go back and adjust the time frame of the reports because they don't keep track of history. So, for example, they may create a report of a geography and they want to know all their customers that are in California. But if those customers move, the system's not tracking that. And so if they run that report again now, it would be inaccurate. A data warehouse takes care of that. It's called a type 2 dimension, where you keep track of as somebody moves or any other particular field. So the reports are always accurate, so you get away from this having to save hard copy reports. Any people here have a big mess of hard copy reports sitting out there in SharePoint? Yeah, it's getting better, but I still run into clients that have that. So restructure and rename the tables and fields. If you ever use some ERP systems, they use names. Sometimes I've seen one at T117, T106. Well, good luck in trying to figure that out if you're trying to create a report. So one of the best things about a data warehouse is as you move that data over, you rename those tables and fields to something that makes more sense in there. So you don't have one guy who seems to be the only guy in the company who understands what all those table names mean. So you go to him and hey, what's customer? T106 joined with T112 and T506, like that. You spend the time up front to rename those fields so The ultimate goal of this is self-service BI, where you can present that data to the user in a data mart or a data warehouse, and they can go, oh, I understand it, I can create reports off that, and not have to rely on IT to generate that report from them. So a big part of that is restructuring and renaming the tables, as well as modeling the data. So that becomes a master data management, which is always a big part, should be a big part of data warehouse, where I see a lot of companies skip. But you should be able to model the data as you bring it over. So you have one version of the truth, but you also have you may have multiple systems that have customer data, and when you want to move it over, you want to come up with an agreement of what those fields for the customer should be, and that's part of the master data management process. It protects against source system upgrades. If you're relying on pulling data from a report from the source system, and it's got all those hard-coded fields in there, and then they change, they upgrade, and all of a sudden all those reports break. I've seen that many times in there. By moving that data over, and everybody's running against the data warehouse, we don't care what changes happen here. We can always change our ETL, but you're not having all these reports suddenly break by doing an upgrade. And then master data management, as I talked about, can include other things like hierarchies. So many reporting situations, you want to have a hierarchy, and you don't want to hard code those hierarchies within the report. So you create a master data management solution that has those hierarchies that you can build into it. And hey, like I said, no IT involvement in there. As somebody's worked in IT, there was nothing more boring to me than having to create user reports. I'd rather just give them the data and let them do it on their own, as opposed to them, James, create it, and then I go back and give it to them, and they're like, well, that's not what I want. And I give them, that's not what I meant, and you go back and forth and back and forth. Unless you really like that, a data warehouse is going to help you out. And then improves data quality, because many times you see as you bring the data over, you start seeing issues with the quality of the data. And every project I've ever been on, there's always some problem with the data. Even when clients have told me, James, I can promise you this, there's nothing wrong with our data. We've got it all nice and clean. Then you start digging into it, and you're looking at, well, some customers have a birth date of 1902, or not 1802, and you're like, that doesn't make any sense. Oh, there must be some problem with our source system. They can go in there and they can plug it, and they can make sure the range is valid. But in the meantime, they had this problem for who knows how long going on there. I've seen heights of people that were under 1 foot in systems. I've seen some crazy things in there, but because you find when users, they have an order entry screen or a customer entry screen, and they want to get through a field and they don't know the answer, they just put some crazy stuff in there. Well, when that comes over, how are you going to capture that data accurately in the report? So you need to clean it up. So that is a big process, and that's probably the most time-consuming process of any data warehouse project I'm on, is cleaning the data in there. And people gloss over it. They don't spend enough time in a project planning for it, and you just have a big mess. Because once you develop those reports and give them to the user, if they're inaccurate to start with, you're going to have the uphill battle to fight, because right away they're not going to trust the accuracy of your data. So you got to spend a lot of time in that. And then one version of the truth. The story I always like to give out is one company, when I built a data warehouse, and I was looking at a financial formula that they were using, and I found that I couldn't balance this formula against all these individual departments who were supposed to be using the same formula. We dug into the details, and we found that each particular department or division had changed the formula. And I asked why, and it turns out that the formula was for generating the gross revenue, and their bonuses were based on that formula. So they would change the formula to exclude or include certain departments or certain products and get a better number for them. So we had one version of truth. Boy, were some people pissed. But it was the right thing to do, and it was especially concerning because this was reported to Wall Street. So I won't say the name of the company, but the idea is you want to have management and other people trust that the data is accurate, and not going to go into these meetings, which I've been in, when people fight over what the true numbers are. And then finally, it's easy to create BI solutions on top of it. If you have a nice built data warehouse and you want to build cubes or you do reporting or any other solution, you have a solid foundation on that. So this is usually the mess I see at a lot of companies, is they have all these particular applications. They want to generate reports off that. They need to hit all these particular databases, and I've seen views that are just staggeringly crazy because they need to join all these sources in there. and it introduces a lot of complexity. So the purpose of building a data warehouse is that nice clean environment you got on the right hand there, where all that data gets pushed into an enterprise data warehouse, and then you can report right off that one system there. So you save time in building reports, because a lot of companies that have that solution on the left, they'll have people that spend hours and hours and hours creating the right report. Because what do? They get the data from raw goods and they export it out into a flat file, and they import it in Excel. Then they go to the MRP system, they do the same thing, and then they mash it all together, and they have these macros, some really amazing macros. But man, they enter a bad keyword in there, or hit the wrong button, and suddenly none of these reports are working, right? And if there's any kind of updates that got to be done in the systems, it's just become a big mess in there. So you save the time, and then allows you to analyze, slice and dice the data in ways you've never been able to do before, because you give them that extra time to analyze the data, and instead of writing or building reports, and they can find very creative ways of looking at the data, and in the end make better business decisions, because that's what it's all about. So some of the solutions, any questions, I'll stop right there and take a drink. Mm-hmm.
That's what they're kind of doing. But there are other regulatory requirements to have those reports be in the organization for, let's say, 7 years or 10 years. How do you sort of manage that? Because the more data you want to put in the warehouse, if you keep the district for so long, you're kind of piling up the warehouse.
So the question is, if you have a lot of data and a lot of years, in some companies, government regulations, I got to keep data over 7 years. Sometimes you usually want to go back and look at older data. So that is where you need to have and I won't get into my Microsoft pitch, but generally you want to have a scalable system or scalable appliance that allows you to scale up as your needs grow in there. Now, traditionally, you can do the forklift approach, where I run out of space, I get a new server, I back up and restore, move with security. Hopefully nobody hard-coded IPs into there that I got to change, which I've done before, and so that's it. So up front, you want to spend time thinking about these things. What am I going to use for data now? What will I usually going to request in the future, and come up with a system that supports all that now and in the future. That gets into a modern data warehouse, which is another architecture, another session I have, where you can buy an appliance that could handle that. But it just comes down to, you got to guess that you have enough space to start out with. Right? And if you get a SAN, then you got to expand the SAN, and it's a big mess in there. But it's a lot of upfront design and thinking about this, and this is hopefully I start you in the right direction of thinking about all these things before you start your big data warehouse migration. So good question. So that kind of leads into some of the hardware solutions. How many people have heard of the Fast Track data warehouse? A few. That's essentially a blueprint for building the hardware in a such a way that you're optimized for data warehouse. So that's something you can download and you can look at, and you can say, I'm going to follow this blueprint and build this software or the hardware on my own. Or you can contact a lot of the vendors and say, I want a Fast Track data warehouse, and they already have it either built for you and you assemble the components, or they can give you the whole system and deliver it and kind of plug in and go. So they have both those options in there. But it saves you the time of installing or building the hardware, in most cases, installing the operating system and doing all the configuration and getting it optimized in there. That problem, which can take months, I've been in those meetings where you sit there and argue what kind of hardware we should get, and you don't want to get something that is too much or too little, and then you got to go through the whole procurement process and people arguing back and forth, and you finally get it delivered, and then who's going to install this and who's going to put it together, and that process can just take forever. The other thing is, to that point, is appliances. There are a number of ones that you can buy already done. So either I can call HP and say, I want all these particular servers or parts of the server optimized for the data, for a Fast Track data warehouse, or they can have ones already built. So some of them, like for Dell, has ones called the HP Appliance 1000 to 2000, IBM, HP, they all have ones that are pre-built. And behind the scenes, this is what they've done to sort of reduce the risk to you, is they've optimized the database and the hardware and the software for data warehousing, so it takes a lot of the guesswork out of building on your own, and you can be much more confident going in that you're going to have a solution that's going to last for quite a while. And they haven't yet come out with Fast Track Architecture 2014, but that's in the works. So let me jump to a data warehouse versus a data mart, because I really didn't have a clear understanding of this when I first started out. Data warehouse has all the subject matters that you want. A data mart will be one particular subject in most cases, sort of a subset of a data warehouse. So you'll build this data warehouse that'll have all your source systems in there, and then you may, for various reasons, such as a department wants certain data that they want to use on their own, or you want to build a cube off of it, or they want to go and take this data and export it out into this special system that they have. Then you create data marts that are subject specific out there. So you can sort of have a hub and spoke environment where, and data warehouse in the middle, and all these spokes are various subject areas. That kind of leads into our further talk with the Kimball and Inmon methodologies. It's fighting on there because if you ever go out to any of the news groups and see people talking about it, somebody will just go, hey, I heard Kimball's a good methodology for use. Then all these Inmon people come up there and argue, or vice versa. So how many people here have heard of the Kimball method of building data warehouses? Most people. How many people have heard of Inmon? So almost the same amount. So I'm going to debunk some myths, because when I first did this a number of years back, I just thought, oh, Kimball's the way to go, and I heard all these bad things about Inmon. And then you start digging into the details, and you find out they're actually a lot closer than you think in their approach. And there's some myths that have happened along the way. So we'll see that there's really a hybrid approach of the two is really the best solution, I feel. So some of the myths is Kimball is a bottom-up approach, meaning I'm just going to create a subject area, maybe create a data mart, and I'm going to build out from there without really any thought going into how it's going to look down the road. And I'll just build these particular data marts on the fly out there without really planning for it. Well, if you talk to Kimball, when I've had this conversation with him, he doesn't like that they call it a top-down approach. He still stresses they spend some time, and a good deal of time, and he'll argue even more than the Inmon method up front designing this system. We'll call it a bus matrix, where you put in all the subjects that you want to use, sort of the fact tables, and then all the sort of the dimension tables on there. And you need to think about this grand plan, and then you focus in on one of them and build that. But you want to have an upfront design, because you're going to have some concordant dimensions, which are essentially a dimension that could be used in more than one subject area. So maybe I have date. Well, that's going to be used in financial data and production data, any kind of production data, whether it be your CRM system in there. And you may have customers that are used in the product data and also in the financial data. So those are the conform dimensions. So you need to think of that up front. So there is time, or should be time spent up front if you're using the Kimball method. And so on the opposite case, people think the Inmon method requires a ton of upfront design, meaning I'm going to spend months and months designing before I'm going to start coding. Well, you know what? That doesn't work. That approach was tried in the 80s, and it failed miserably, and that's kind of where I think this got a bad name for doing that. But if you check the sources of Inmon, and I talked to him about it too, is he says, yes, you need to spend time up front designing the system there, but not a lot of time, not like a big bang approach in there. He said, it's like building a city. You want to design out the city, but you don't go and say, I'm going to build the entire city from beginning to end and then have people live in it. You build parts of it along, and that's what his approach is in there. So there is time spent up front designing in there, but you can code, you can do the agile approach in there, because I can't go to a client and say, you're not going to see any code for 3 months. They're just not going to have it in there. So you got to start showing results right away, and he understands that. Another myth is the star schema. So we'll get into that a bit more, but you have the relational model and the star schema model, and people think if you use the Inmon method, then you're not going to use the star schema method. But he actually quotes in some of his documentation that star schema should be a part of his solution. You can have an enterprise data warehouse and then have data marts that are in star schema format. It's not something that's forbidden in his model like that. And then this was a study that was done a couple of years ago that showed that actually there's more companies using the Inmon method. Now it's loosely defined, but essentially if you have an enterprise data warehouse where you have one large warehouse with a lot of different subject matters, that's more considered a Inmon method than a Kimball, where you may have a lot of separate data marts in there. Again, you can argue this back and forth, but in that loose approach, there's actually more companies, and I find this in my case, that they have a gigantic enterprise data warehouse. Oh, and the last one is that they can't work together. So you talk to either one of those sides, and they'll blast the other, and one will blast the other, that they can't work together. But in the end, most of the solutions I find, and the best solutions I find, are a combination of the two. So any questions on that? Any Kimball people are going to start throwing stuff at me? Inmon is more of, you read his books, he concentrates a lot on the relational model, and then Kimball talks a lot about the dimensional model, the star schema. So neither one of them invented those technologies, but they delve a lot into those. So the relational model is your basic third and fourth rules of normalization in there, where you can wind up having the data normalized so there's not a repeating of the data everywhere, but it could result in a lot of joins, because you can have a customer table that may be 10 tables in there with no repeating data. Pull that data together, you need to have a lot of joins in there. You could have history tables in there to track some of those things, like somebody moving across states. And then it's usually good for indirect end user access of data, meaning it's kind of the first stop, and then a lot of times people lock down their enterprise data warehouse and they build data marts from it, and they don't allow people to have direct access to the EDW in there. So that's why it's good for indirect access. And it's usually a good first step. If your source system is relational and you move it over to data warehouse, sometimes it's better to keep it in that relational format, maybe do some denormalizing and cleaning things up in there, and then move it on to a star schema. But you have that intermediate step, because it helps with your ETL process of not making this big jump go from source system right to the star schema. So the dimensional modeling is the star schema. How many people here know what star schema is? Everybody raise their hand? Good. There's one person who doesn't. Let me explain it to you. No. So I won't get into that, but I always have to say, when I first heard of star schema, 8, 9 years ago, and then denormalize it, I was like, are you high? I'm going to copy all this data? But there's two big benefits that you find out that as you start using that approach. Is one is, as like I said before, you present it in such a way that it makes a totally understanding for the user to create their own self-service reports on there. They can understand the star schema very easily. And it's also for performance. If behind the scenes you have it all relational and you're joining 20 or 10 tables together, as we know, joins can take a long time if there's a lot of them. And so by ETL process creating the star schema, you're enhancing the performance when you run those reports. And then allows for slowly changing dimensions, again, moving across states. You track that in a type 2 dimension. And then it's usually the best way for direct end user access of data is the users will be reporting right off of that star schema. And behind the scenes, that may be built from a relational model, but that's the indirect access. So you're probably familiar with this then. There's which, if you're a business user, which is the best to use? Everybody's going to, well, I don't know, unless you're crazy, but you can say the dimensional model. So the Kimball methodology has what it's called a logical data warehouse, a bus architecture, made up of many subject areas, each with its own data mart. However, that data mart can be within its own data warehouse. It doesn't have to be separate, and that's a lot of confusion I see people. They think a data mart means it's all separate, but a data warehouse can just have separate schemas, and those can be each of the data marts within the data warehouse. It's usually more business driven in that when you're building it, you may have a lot more interaction with users to help you build that, and I find that very true. The decentralized data marts, meaning they don't have to have a separate physical data store in there. So that's kind of my previous point. And it's independent, meaning they don't rely on each other for reporting purposes. We can create a data mart that's self-sustaining. So if you give that to a department, they don't have to go and join it with another data mart in there. You want to present a data mart. So a data mart could have multiple subject areas in some cases in there because you want to keep it independent. And then it's two-tier. The benefit being is you may have data in a source system, so it's copied to a data mart and then to a cube. So it's really only has two other copies of it. So there's less ETL, less data duplication for that situation. Inmon they call it as CIF, which is just another name for enterprise data warehouse. More IT driven in that a lot of time up front is spent by IT designing it. They still have interaction with the users, but because it's generally a lot more subject areas to start out with in there, and IT is a little more involved in that. So he usually has a centralized off-limit to users. That enterprise data warehouse shouldn't be touched. Now, I find that pretty rare, but sometimes it's a good way for security reasons to have it off-limit to the users. And so if that's the case, what you'll do is create the data marts, which are dependent on the EDW, and so everybody will access the reporting, the reports using those dependent data marts. And then the 3-tier is where you have one extra copy of the data because you go from source system to the data warehouse to a data mart and then to a cube, so you can have extra copies of the data, which could lead to some problems. So here's what the Kimball methodology model looks like, where you have your, let's see if I can get this working. Data sources go into staging areas. From that, you'll use usually SSIS or ETL tool of choice to get data marts out of that. And from each of those data marts, which again can be just star schema subject areas within a data warehouse, so they don't have to be separate. But from that, you can create a cube or you can access them directly. And that's sort of the classic Kimball model. The Inmon model, same idea with the staging areas, but from there you put them all into a data warehouse that maintains a relational layout of the data in there. However, from that you can create data marts that have the normalized, so you're breaking out the data, and then from that you can create the cubes on there. Now, this right here is always what people argue is, can this be star schema? And Inmon said yes, it can be star schema in there, even though I show it normalized on here. So, and then people will argue, well, why do I need an enterprise data warehouse? Why not just have a bunch of data marts in there? And I always say, well, if you have data marts, a lot of times you have multiple versions of the truth because finance may want some data of forecasting data, and then another department, product company may want some forecasted data. So now you have to copy that data over to 2 different spots. So yeah, they're separate data marts, but they have some duplication of the data. And then you run into problems where some ETL breaks and now you have 2 different copies of the data that's not in line with each other. It also makes building dimensions easier. As I talked before, if you go from relational right into star schema, there could be a lot of difficulty in that transition and writing the ETL from that. So instead, I like to find it, especially if we're dealing with a lot of different tables, is to move it over into an enterprise data warehouse, do some denormalization on there, and then create the star schemas on there. It's kind of breaking out a complex problem into a couple of different steps in there. So if you do create that EDW and you want to spin off data marts, it makes it a little easier because you're not having to create data marts from the source systems. Instead, you have this one area that you can build a data mart from like that. So it leads to a lot less complexity. And it makes it easier if you have all the data in there and somebody says, I want a new data mart, hey, no problem, we've already got it nice and clean in this enterprise data warehouse. Just pick and choose what you want and we'll create your data mart for you. But there's expensive, again, duplicated data in there. So it's less ETL. So again, if you have, I've seen clients where they have a lot of different data marts and a lot of different data sources, and it becomes a big spaghetti mesh of data from ETL sources going all over the place in there. Well, that becomes greatly reduced if you have one dumping ground for all your data and then build data marts from that. So again, as we're kind of repeating it, no duplication of effort, because if you create a new data source or a new source system in there, you may have to update multiple areas of ETL to update multiple different data marts. If you just use a enterprise data warehouse, you're not having to repeat that process over a bunch of different data marts instead of just one data warehouse. And again, like I said, it's not one solution fits all. There could be reasons not to build an enterprise data warehouse. If you only have a few data sources and users are clamoring for something, okay, maybe that's a good case for bypassing EDW. However, I always see that turn into a big mess after a while because the users will give them something, then they want more, and then you start, okay, let's just keep plopping on this temporary solution we have, and it becomes a big jumbled mess down the road in there. So which model to use? Now I've explained both of them. Again, they're not that much different. They've become very similar over the years. If you look at many years ago when they first came out, they were kind of set apart. But over the years, they both made changes to their model, and suddenly you're like, well, these are pretty close to being the same now in there. And that results in a lot of ways that they can complement each other, which we'll show a slide in a minute. So it really boils down to two things. And Inmon creates a normalized data warehouse before creating the dimensional data mart, and Kimball skips that normalized data warehouse or that enterprise data warehouse in there. He goes right from the source system to the star schemas in there. So we'll tweak to each model that they're going to look the same. If you take those approaches I had before, and you just add a normalized enterprise data warehouse to Kimball, or you add those star schema data marts to Inmon, they pretty much look the same, right? So the bottom line is just understand both approaches and find out what's best for you. No one solution is going to fit all your needs. Even if you pick a solution, some particular data sources may come in that you'll want to make, maybe you need to take shortcuts on there because you don't need all the steps that are going through the other data sources in there. So keep that approach. And I always like to point out this, I don't care what approach you pick, have somebody who understands the technology, who understands the architecture, can be a leader and communicate and plan and build those personal relationships with all those end users, because the biggest failure I see among these projects is when people go and build it on their own, they don't get involvement from the end users, the ones who are going to generate the reports, or they don't communicate what they're doing, they don't get buy-in, they don't have a champion on that side. You're going to go and build it and nobody's going to use it, and I see that many times. I heard stats that 70% or 80% of the data warehouse projects fail, and I tend to believe that because a lot of times I go in as a consultant was cleaning up after messes, because usually the end result is they may have had a good architecture, but they didn't have somebody in charge that was communicating and running it effectively. So here's the hybrid model. If you have your source, if you have your source systems, again, you want to have the staging area, but here's where we add. We have a corporate information factory, that normalized data warehouse, and then we have, from that, sort of a hub and spoke where we have those star schema data marts in there. And then from that, we build a cube. So this area right here is just the part from both of them that are on this particular solution in here. And I see most companies using this. Again, you can skip certain areas. Maybe I have a small data source in here. I can move it right into here. I can move it right into here. But if you have a sophisticated data source, you usually want to have all these steps in there. And I always put OLTP mirroring here because you want to reduce the time spent pulling data from your source system into the staging areas, which could be very time consuming. So if I create a mirrored solution off that, I'm reducing the performance impact on the source systems. Questions?
Is there a difference in the way they implement data quality in the two approaches, where they implement it, how they
Good. You asked about data quality, and that's a good segue. I have a slide coming up that shows that. Yeah, I always have a good segue guy in there, and I only paid him $10 to make that question up. Right before we get to that, a lot of people say they use Kimball, and they're really talking about not so much the details on the architecture, but the whole methodology that Kimball's have. If you never read this book, I always press the wrong button. If you have not heard of this book, the Microsoft Data Warehouse Toolkit, that's the first thing you should go and buy that and read that. And that goes through this whole life cycle of building a data warehouse. This one is specific to Microsoft, but he has other volumes that are vendor independent. But this is the always thing I tell people to read. This is the Bible. And this is what's inside that book. It talks about going from anywhere from planning the business requirements to building it out to deploying it, maintaining it in there. So Inmon doesn't really cover any of those, that whole thing. He covers one very specific area. So you can, in some ways, be doing an Inmon implementation, but still follow the Kimball methodology from beginning to end in there. So populating a data warehouse is another important aspect that I see many clients failing at. What do we go to? 5:30? I'm Eastern time. 2:30, right? Okay, I got 20 minutes. I start talking and I lose myself and I lose track of time. They don't have any clocks on here for me to judge, or somebody going like this. So populating a data warehouse, the first thing you need to do is determine the frequency of how often you're going to pull this. Is it a daily, an hourly, a weekly thing like that? Are you going to do full extraction, which you can do successfully for a dimension table? I just want to trunk and load it. If the data is small enough, that'll work fine, and I recommend that approach. But that doesn't work if you have a lot of dimension data, because it could take too long, or if you're doing that type 2 where you want to keep track of the history of somebody if they move from a state. You don't want to use a full extraction in that case. So you want to do an incremental then. So you only get the data that's changed from the last run. Well, that's great, and that's worked for most fact tables, but then how do you determine if the data has been changed? Well, hopefully you have a timestamp on there, but many ERP systems don't have a timestamp, or they have one that's not used. So what are the other solutions? Well, you can use change data capture if you're using the SQL Server Shop, and that'll have an audit trail of everything that's been changed. You can do partitioning by date. I've seen that solution. I've seen people put triggers on the tables when there's add, update, or delete, and put that in an audit table. The merge statement is good if you want to compare all of your source system with all your target system and do an update, insert, and delete, sort of combining those separate statements into one. And then some clients will create a default value populated with the date and the source system and then use that to track what's changed. Because that's the end result is if I need to move this data over incrementally, I need to know what's been changed since then. And so these are some ways to do that. The other thing to think about is online extraction. Ideally, we'd like to be able to connect directly to the source or to connect to a replicated source, but a lot of times you can't do that. If it's a system that's not SQL Server or it's not located where you can have direct access to it and you've got extract files in there. But if you can get online, then the ways of doing that are through replication or mirroring, availability groups, which is new in 2012, or create a database snapshot, and that gives you an online extract of that data. So that gets you your copy that you can then pull into your data warehouse solution. If not offstract, if you cannot get access to it, you may have to get data from a flat file, which involves dumping it into a folder and then pulling it into your source system that way. So the ELT versus ETL is a big part of this, of creating a proper solution there, because what you see is people doing a lot of transforming that T and the ETL in there. And as you pull data from the source system, you transfer it and you put it into the data warehouse. Well, that's great, except if you are hitting a source system and people are hitting that in production in there, that transformation time could be eating up the performance issue on the source system. So instead, most clients I recommend ELT, where you use staging tables, you pull that data as quickly as possible, dump it into your data warehouse, and then start processing in there. So you're minimizing the impact on your source system in there. And you almost always have to do that for big volumes of data. But you can only do that when the source systems are the same. And I forgot to change the name. The parallel data warehouse is the common solution. This approach is common for what's now called APS. That we always do ELT in there. So just a common mistake I see is people spending too much time in that load process. SSIS is great in most cases, but if you want to transfer data, it's got to copy the data into SSIS, put it in memory, and that process can slow down the performance and therefore affect the people hitting the source systems on there. That's kind of what I just said. So the database engine a lot of times is the fastest for doing that transformations. But you can still use SSIS, so I see a lot of clients kind of using it as a data pipeline and workflow management. So though that SSIS may call stored procedures that do all that transformation, so you can look at SSIS and kind of see the flow of how it all works, but behind the scenes it's calling stored procedures to transform the data. So surrogate keys are another concept that, how many people are familiar with surrogate keys? Most. I'm preaching to the choir. So and I've rarely seen people do successful data warehouses without using surrogate keys in there. So these are all the reasons that you're probably familiar with. Some of them that you may not think about is the slowly changing dimension. Some people don't think about that up front, and then they create their solution, and once you create it without the slowly changing dimensions, you really can't go back. So just think of that up front. And to use surrogate keys, to use slowly changing dimensions, you need to have surrogate keys in there. Cubes. How many people know what SSAS cubes are? Wow, this is a great Microsoft crowd. I can almost be quiet. So anyways, there's a lot of reasons to use a cube. Even if you have performance really fast on your data warehouse, you still may want to create a cube from that because of such things as you can store hierarchies and KPIs. You can use Excel pivot tables, which everybody loves on there. You can have time calculations on there. So, so keep that in mind that cubes will still be part of your solution in most cases, even if you've got the fastest data warehouse in the world. So here's the segue that I took a long time to get to is here where we see the source systems come in, and then we have DQS or MDM. Those are Microsoft Solutions, data quality services, or master data management. That's where it usually comes in before you get to the data warehouses where you do all this cleaning and mastering in there. And then once it gets mastered, then you distribute it to data warehouse. Some companies have an ODS, operational data store, which is more of a real-time approach to getting reports more quickly. And I say instead of having a real-time data warehouse, most times you'll be satisfied with an ODS. And most times you'll be satisfied, and surprised how many times people come say, okay, I want a data warehouse, I want it real-time. Why? Well, I want inventory counts, updated per minute. Okay, why can't you just get that from the source system? Well, I could. Well, okay, you have to understand that a data warehouse does not mean every single report needs to go from the data warehouse. You can still have reporting off of the source system, and many times for things like those real-time inventory counts, it's still better to stay with your source system. Now, if you have multiple inventory systems, that's where the ODS comes into place. I may want to create a system that's going to mush all those inventory counts together in real time, but I don't want to do that in data warehouse. Data warehouse, think of it as reporting after the fact. And a lot of companies, they don't want numbers in the data warehouse during the day because they want end-of-day reporting. That's what they're going to use. So just keep that in mind too. But what we're seeing most solutions involve is once you build the data marts and you build the cubes off top of them, the landing of all the data is shared via SharePoint. Most of the tools nowadays are using SharePoint as the landing zone. As you saw in the keynote today, Power BI is a big one, and they're integrating more and more with SharePoint, and hopefully on-premise will be everything soon. So questions up to that point? Before I jump in, I got 10 minutes to go.
Yeah, what about the surrogate key use? Is that permitted in an architecture, or they rely on natural keys there?
Yeah, so the Inman usually talks about natural keys in there, and so, but he has given leeway to surrogate keys in there. He'll argue against that sometimes. But the natural key, the problem is what happens if you use a natural key and you integrate two systems and they both have customer numbers that are the same in there. And that doesn't work also if you are using the slow chain dimensions and you have to have some uniqueness in there. So they'll sometimes say, well, we'll just merge two fields together, or just have some short, we'll call this system S1 and S2, and then merge it with the unique key in there. But I don't like doing that. I just like sticking with surrogate keys in there. So I always recommend that. And you still usually want to move your those keys into the source, into the data warehouse. This way you can match it back to the source system if need be. So don't get rid of them. But in addition to that, have the surrogate keys in there, in addition to the natural keys in there. Good. Questions?
With ELT, is it presuming that your stage area, your data warehouse are all on the same server? Because, cross-database joins,
right.
SSAS scaling, doing it in memory, that's one of the advantages. But ELT kind of goes away from that.
Yeah, so the question is the staging database, where is that usually located? And yes, it usually is on the same server. It almost always is on the same server as where your data warehouse is going to reside. Otherwise, you're not really getting the benefit of that. So I always tell companies, pull that data over as quickly as possible into where your data warehouse is going to eventually lie, and then process it from there. Because you're not having that bandwidth connection of something somewhere over in another state and your data warehouse over in this other on-prem solution, Yeah, good. That's another, yes?
How essential in the whole data warehouse architecture are cubes?
How cubes?
Yeah.
How often are cubes used?
Yeah, how often is cubes, and can you have like a good reporting delivery without cubes?
Yeah. So can you use cubes without reporting? Again, if your data warehouse is so fast, I see companies getting away from using cubes, and you can use column store indexes now to get a tremendous performance out of that. And that'll be great, and I will say just go with that unless you find a need such as I want to use performance point, requires a cube. Excel pivot tables requires a cube. I want to use hierarchies, KPIs, that one slide I had before. So your cube, even if you're getting great performance and want to use rollout mode, real-time access to the cube, which we use in the PDW, because it runs behind the scenes, it creates the queries, and they're so fast that you don't need that benefit of the cube of aggregating data. I mean, that's why you create a cube. I can't get the data fast enough, so I need to aggregate it and run that process at night, right? The two problems with that is the processing could take a long time and hit into users hitting the cube, and also your data is only as late as when that cube was processed in there. So a lot of companies are going to rollout, especially if they have a fast enough appliance to take care of those two problems in there. It's a good question. So I'll jump to the modern data warehouse and I'll take some more questions. So this is a new approach. I have a whole other presentation on this, but some of the things you start thinking about if you're doing a data warehouse, a new one or you're re-architecting is the data volumes, as we talked about before. What if you want to incorporate many terabytes or if not petabytes of data? If you want that real-time performance that the users are expecting to continue, you need to think of, well, if I add more data, is it going to slow them down? And in most cases, it is. So you need to have an appliance or some solution that's going to be able to scale without affecting users expecting those data to come back in seconds. It needs to be able to handle new data sources and types. That could be unstructured data or non-relational data, Hadoop data. How many people here know Hadoop? Have heard of Hadoop and kind of understand it a little bit? Know a little bit, 75%. How many people here have a Hadoop solution in production at their company? One guy, two guys, three. He's lying. He just likes to brag, and he's right. So I gave this presentation. Giddy up. I like that guy. So I gave this presentation the other day. There was 200 people in the room, and everybody knew it because it was in a Hadoop session, and there was 3 people who were doing Hadoop in production. So everybody's talking about it, but they don't quite understand the use cases. As I dive more into that other particular session, I talk about the use cases of where you can use it as a staging area, you can use it as a backup area, and so on there. But you need to think about if I need to incorporate Twitter data or any kind of social media or real-time device information, I need to have a system that's going to support that. And the other is the cloud-borne data. So there may be data that originates in the cloud, and you want to import in your data warehouse. I have some companies that say, well, we don't use any cloud. It's a bad word. But then you start asking them questions. Well, where's your payroll data, employee data? Oh, yeah, we use APS. So I guess we do some cloud stuff, and we might want to import that. Or we're using Salesforce. So you need to have a system that can easily import that in there. And that's where the analytics platform system comes into place. And there's competitors that have something similar in there. But the end result is you want to have a system that's scalable where I can start out with a small, maybe appliance there, but able to scale it as my data needs grow in there. So instead of having a forklift and back it all up and restore it on another appliance, I can slide it in another rack, and the data can be redistributed among all those scale units with little involvement from IT. You also want to have, for a large amount of data, to get that real-time performance, an MPP, a multi-parallel processing architecture, where the queries are redistributed among various servers, and the results calculated independently and then brought back to the end user in there. So it's a scale-out solution. So as I add more and more data and need more and more performance, I can add more servers out this way and redistribute the queries and keep the same performance, if not improve it, as my needs grow in there. Instead of the scale-up where you hit a limit with your hardware and you're kind of stuck, and you got to buy new hardware. And finally, Polybase is a technology that is used to join data from relational model and a non-relational. So I can have in the same system a PDW region that has regular SQL tables, and then I can, in this other Hadoop region where I have unstructured data, I can put structure on top of that, meaning I can do a create table and point it to that file that's sitting in Hadoop and give it that structure so it's treated just like any other table. And the user has no idea that behind the scenes I'm pulling Hadoop data in there. So when you create that environment, you can create a join that's going to join that relational and that Hadoop data in the same SQL statement, and the polybase is the kind of the glue that does that. And it allows the users to use regular SQL and pull that data together. Well, behind the scenes, it's actually doing all this crazy stuff with Hadoop in there, but they don't know that in there. So just think about those 4 things when you're designing a data warehouse. And even if you say, well, I don't really need Hadoop now, but I think in a year or 2, I'm probably going to use it. Well, you don't want to build a system that doesn't support Hadoop, and then in a year or 2, you're redoing the whole architecture again like that. So again, this is another presentation I'm giving for Pragmatic Works in 2 weeks online. And I'll dive more into that modern data warehouse approach and that. So questions?
Do you see a time coming where I can have an enterprise data warehouse that's been normalized, where I don't have to persist my star schema, where I can just have views that be my star schema, that I'll not have that persisted anywhere? Basically, when I hit my star schema, I would be just hitting views of the star schema.
Yeah.
Just think with the PDW, is it necessary anymore to make that copy again?
No. So the question is, do I have to use a start schema in all cases, especially with a fast appliance? And I see a lot of clients who don't create a copy of the data in start schema. They may create a view, but that view runs so fast, the end result is the view is building your start schema, which you still usually want to present to the end user, but behind the scenes you're not having to go from relational to a start schema. And so I'm seeing that happen a lot now, especially with the PDW in there.
And I can also point that to my cube.
To that view, right.
Directly to the view.
Yes, you can point your cube. To the cube things as a start schema, really it's a view. And that's a common approach there. And the beauty is you're not having to copy the data again in there. And a lot of that goes back to the size of your data. That's why I said that model, that hybrid model, you can skip steps. If I have a small number of tables, do I really need to copy it for performance? No, I can just have a view. Hell, my view can go right against the source system and create to the end user a start schema, but behind the scenes it's not going through all that extra rigmarole in there. But you definitely need that for data that is a lot more of it. Good question. Other questions? Sir?
What other landing platforms or reports do you see other than SharePoint? I found that SharePoint's not one of them.
So he said SharePoint is great, and he loves it, and he wants to know what more tools are in there. And you asked this to a Microsoft guy. Thank you.
Yes, I do.
Are you with Tableau or no? So there are other competitors that have BI solutions that have a server or a landing zone of that. ClickView's one. I don't know too many others in there, but some of them, and then some of them work great. When I see some third parties that try to do everything and they have their own special way of pulling out the data, that can work until you start to scale, and then you have a lot of problems with that. And then their solution sometimes is boxed in where if I want to use Power BI or any of the Microsoft tools, which are way better, they won't work on some of their solutions in there.
Well, I'm just thinking, not another competitor, just not using it at all. We found that it just seems like everyone's sort of siloed together using Excel for the most part. But they don't necessarily share.
Yeah. And that's where Power BI's come in place, because now you can use Excel to pull data into there, and you can share those queries with other users in there, and you're not having to use SharePoint in that particular situation. So and that's one of the things I love about Power BI is they create a data catalog that allows you to upload all the metadata about all your queries, and then other people can do a search and they can find, hey, you wrote a query that has some of the data that I need, and I'm going to use that inside of Excel, and I'm never leaving Excel and that. And so Microsoft saw the benefit. I mean, I'd love to say people are going to get away from Excel if you show them a great tool, and Power View is a great tool, but man, people don't want to learn something different, and they're familiar with Excel, and they want everything to be in Excel, and that's why the Power BI is just an extension of that in there. So good question. So with that, I'm running out of time. I explain a lot of this in more detail on my website, a lot of blogs about all this. The slide deck will be there. It's also on the past site. And then there's my blog at the bottom. on there that has more information about all the topics I talked about. And feel more than free to email me. If you have any particular questions about your situation at work and you want to run it by me, that's what I get paid at Microsoft to do, essentially, is help companies understand their current architecture and where they want to go and how Microsoft technology applies to all that. So I thank you for your time, and I'll be here for questions if you want.